Okay, so in this video, we are going to look at the mathematical definition of an epsilon NFA. So we have already looked at the mathematical definitions of a DFA. Then we also have seen the mathematical definition of an NFA. And now we are interested in looking at the mathematical definition of an epsilon NFA. Okay. Now, before going to the mathematical definition itself, we shall look at this epsilon NFA. So the peculiarity of epsilon NFA is that it has got epsilon transitions. You can see there is an epsilon transition here. So this is an example of an epsilon NFA. So there can be multiple epsilon transitions also. So an epsilon NFA is nothing but an NFA. So NFA plus epsilon transitions. So if you have, all the properties of an NFA are also valid for an epsilon NFA. Again, the additional thing that we have in an epsilon NFA is the epsilon transitions. So this has to be accommodated in our definition. That's the only thing that we need to do differently from the mathematical definition of an NFA. So the mathematical definition of an epsilon NFA is very similar to the mathematical definition of an NFA. The only additional thing that we want to take care is that we need to have epsilon transitions also defined. So let's look at how it can be defined. Now, if you remember, this is how we represented the mathematical definition of an NFA. So again, remember that the transition function was defined from Q cross sigma to the power set of Q. So Q cross sigma essentially means the Cartesian product of states and the alphabet set. Okay. So remember very importantly in epsilon NFAs, we are also going to define transitions on epsilon. Okay, so we have to accommodate epsilons also in our transition set. So what we need to do here additionally is that instead of saying Q cross epsilon, we should make it very clear that epsilon symbol is also is a valid transition for the epsilon NFA. So what we should do is that we have to add the epsilon symbol also as a valid transition. So we have to say epsilon union, sigma union epsilon. Okay, so this is very important. So the Cartesian product is defined from Q cross epsilon sigma union epsilon. Okay, so this is going to be sigma union epsilon. And then it is defined to 2 raised to Q itself. That is nothing but the power set of Q. Now the additional symbol that you are taking here is the epsilon. So you can actually mark it with the set symbol. So this is how we the modified definition for an epsilon NFA looks like. Now the only difference that you see here is this accommodation of this epsilon symbol also in the Cartesian product. So remember, epsilon can also be a valid transition. Okay. So if you look at this diagram, so there is a transition function defined on Q2 comma epsilon, right? So the transition function on Q2 comma epsilon is actually mapped to Q0. So you can, from this diagram, you can understand this. So the transition function on Q2 upon getting epsilon is, you can, let me take my pointer and things will become more clear to you. Okay. So if you look at this NFA here, so from Q2 you are having an epsilon transition which leads you to Q0. So I should have a provision to write delta of Q2 comma epsilon goes to Q0. Okay, so that's why I am accommodating this epsilon symbol here. So epsilon symbol was not required in the case of an NFA where we don't have any epsilon transitions. but we do have epsilon transitions also in our epsilon NFA. That's why very importantly we have to accommodate this epsilon symbol also as part of a transition, right? So that this is the only difference of defining the mathematical definition of an epsilon NFA from an NFA. So all other things remains the same. Q is the set of states, epsilon is the set of alphabets, and delta is the transition function, Q0 is the starting state, F is the final state. All these things are going to be the same. The only difference is in the definition of the transition function. So the only thing that we are doing here is we are accommodating the epsilon symbol also as part of our transitions. And again, remember, this Cartesian product is mapped to the power set of Q itself. So instead of having, the same mapping can be done to different states. Okay. So for example, I can say this is mapped to say Q0, Q1. So there is nothing wrong in having an epsilon transition back to Q1. Okay. So this is perfectly okay. Okay, for an epsilon NFA. So that's why that's how we define the mathematical definition of an epsilon NFA. So importantly, you have to remember this fact. So so the accommodation of epsilon symbol for the purposes of transition is very important.